Yeah,
So are you down in the cavern right now?
I am, yes.
Okay, so you're in front of the detector itself. Okay.
Right, so what you're seeing in front of, hopefully at the moment, is in fact a piece of the end cap of the calorimeter, which has been extracted to its almost furthest open position. And we'll walk around so you can see more the center of the detector in a moment, okay? Do you understand?
Yeah. Please go ahead. Show us more.
So first of all, I should say, you know, we're basically 100 meters underground here. And so above us, there's the access shaft where all of the CMS experiment was lowered down here around in about 2007, 2008. Each of these rings and discs was lowered as a separate unit. In fact, we put the whole detector together upstairs, first of all, and then we lowered it all down here piece by piece, and we rebuilt it down here.
Cuando se construyó el detector, todas las partes fueron bajando por ese túnel que ven ahí. O sea, se ensambló, no se bajó obviamente todo el detector, sino que se fue ensamblando parte por parte y todas las partes fueron bajando por ese túnel que ven. Go ahead, please.
Yeah, everything about an experiment like CMS depends enormously on our engineering, okay? Both electronic engineering, electrical engineering, mechanical engineering. Although we as physicists maybe are the ones who design and do a lot of the prototyping of the detectors that we want, as you see from the scale of this thing, this is a massive piece of engineering as well. You get some little glimpse about how many cables are coming out of this detector. You see basically the cables.
Llevan las señales hacia las computadoras para el procesamiento. Se pueden ver todas las señales. Todos los cables que van ahí están conectados a detectores. Y los detectores.
In fact, yeah, I don't want to interrupt you, but what you're seeing there basically, in the red is iron. And this is basically the return yoke of our solenoid magnet, okay? In the center, where we'll see a little bit better in a moment, we have a superconducting solenoid with runs at about 18,000 amps, close to 4 Tesla magnetic field. It's a solenoid, so that magnetic field is passing longitudinally in the direction of my finger, I hope there, basically in the center of the detector. And in an normal operation,
que se tiene, que es el responsable de deflectar a las partículas para medir su momento, básicamente. De un valor de 4 Tesla, que es un valor muy grande del campo magnético. Entonces es el que se usa para detectar el momento de las partículas, sobre todo para las partículas cargadas. Yeah, please.
So now I'm actually going to, first of all, I'm going to move around so we can see where the middle of the detector normally is, and from there I can sort of describe as we go out like a particle going from the collision point to the tracking detectors to the calorimetry to the muon system. Okay, so I'm going to walk along, and hopefully the camera is going to follow me. By the way, I know you notice if I show you something, you're having a very special tour because where you're going is normally no visitors beyond this point. Okay, so you get to see things that. Actually, if you come to CERN as a visitor, you don't get to see. So we're going downstairs to the floor of the cavern. Okay, I'm going to show you a couple of things down here before we move into the center. First thing you might notice is you see these giant discs in front of you. I don't know if I step backwards, you can see. I'm getting used to the idea of which way moves the camera, up or down. Sorry. Okay, you see, we're actually this is the back. This is normally the external surface of CMS. Okay, and normally this is about 12 meters further to the left hand, further to your left than you're seeing it now. These devices, weighing typically between a few hundred and 1,000 tons, basically these discs, are supported on these orange, you see these orange pads at the bottom here? Yeah? There's one here and there's one on the other side. And effectively, when we move these discs in and out, we float them on, we pump, they're almost like little hovercraft, basically. Basically, you pump air out through this pad at the bottom there with an oil, where there's an oil surface there, and then it glides. And these large cables, as you see here, are part of the pulling system, which open the detector or close the detector, depending on what we're doing. So right now, there are three of these discs which make up the. Let me try and get a sensible angle on my camera again. There are three of these discs that make up the end cap of CMS, and they're basically here. You see the innermost one, the one closest to the interaction point, has this big bulging.
Como todas esas capas que se mueven, ya que pesan cientos de toneladas, entonces tiene que ser un mecanismo que cuidadosamente los muevan y los separen cada. Se le llama el end cap, pero básicamente son digamos los elementos, las piezas de ese detector que tienen que ser removidas para trabajar sobre ellos.
So you see in front of us, in fact, is the end cap calorimetry. This will eventually move into the left and close up, so we have a hermetic detector. But the front part of the detector, so if I can point it here, basically is electromagnetic calorimeter, and then behind that we have hadron calorimetry. In the electromagnetic calorimetry, we basically try to stop all the electrons and photons and measure their energy, whereas charged particles and neutral hadrons like protons, pions, etc. They will pass largely undisturbed through the electromagnetic calorimeter, but they will give up their energy in the hadron calorimeter behind there, where we measure again their energies and we measure which direction they're going in, basically. And then further out in the end cap on these discs, you see all these detectors which are labeled like ME, and RE. These are muon chambers, so that basically, largely speaking, the only things that get out to this part of the detector are muons, and we have basically three layers of detectors here which measure the trajectory of muons. And Alfredo can describe that probably better there for you.
Esta parte que comentabas son los calorímetros que se encarga de detectar las partículas como los electrones, los fotones, partículas neutras también, depende de su naturaleza. La otra parte que está más hacia afuera, esas digamos, trapezoides que se muestran son detectores de muones. Los muones interaccionan más débilmente con la materia, entonces son capaces de traspasar la materia y dejar casi sin dejar señal. Por eso que la última capa del detector son de muones. Entonces, cada elemento del detector se hizo considerando la interacción de las partículas con la materia, ya sean partículas cargadas, partículas neutras, y cómo interaccionan básicamente. Yeah,
okay,
please go ahead.
Yeah, no, so now, so this end cap is behind me on my right-hand side. On the left-hand side, what I'm focusing on now is the first one of 5 rings, basically, which are normally in a closed position with no gaps between them. We're going to walk between the gap in a moment, but they normally have no gaps between them, and they represent the return field for the magnetic field, the return path for the magnetic field. That's the red iron, with muon chambers again interposed between. There are 3 layers of muon chambers here labeled things like MB 2412, you see, and there's another layer of muon chambers further in, and a 3rd layer, and in fact also effectively a 4th layer right on the inside on the inside surface. Okay, so I'm going to follow normally through here. We can see maybe. Yeah. Oh yes. Here we see a nice view. You see, we're looking through one of the end cap rings towards the. In the center there, you see what looks like it's covered in aluminium foil. That's basically the vacuum, the cryostat chamber. What you're seeing, very simple. All the little things wrapped in aluminium foil are basically cable trays taking cables out. But there's a cryostat cylinder there which holds the superconducting coil. Yes, sir?
Yeah, I just showed it with my finger.
Yeah. Oh, right. Yeah. Yeah. And so inside here is do you remember the length? How long is between YB? It's about 7 or 8 meters.
So 1 wheel is 2.5 meters.
Yeah. So we have 5 times 2.5. So yeah. So about 12 meters actually of of cryostat with magnetic with the superconducting coil in the inside and with the ion and the muon system on the outside. We're going to climb up now to go up on top of that scaffolding there, so you can at least get a bird's eye view of what things look like if you're a proton about to come in and die in the middle of CMS. Okay?
Yeah, great. So, now ahora él va a ir bueno, al centro básicamente para que tenga una perspectiva por dónde vienen los haces básicamente cuando colisionan.
Realmente está teniendo bastante acceso ahorita.
Tiene bastante acceso, sí.
Porque normalmente es muy difícil llegar donde está él.
No sé si recuerdan la película de Ángeles y Demonios. Ahí al inicio de esa película se ve, creo que en ese caso es el detector Atlas. Bueno, en ese caso es el detector Atlas. Obviamente lo mezclan con ficción, pues, pero realmente sí es una imagen del experimento. Bueno, Atlas, CMS, digamos, es como la competencia o el par de ese experimento, básicamente. Y en esa película se relata cómo vienen las partículas, chocan. Bueno, ahí decían que se creaba la antimateria, ciencia ficción. Pero básicamente sí pasa que las partículas van viajando y llegan a chocar en el punto de colisión. Cuando ya hacia el
Okay. So now if I can come back to you, now we're looking at the end cap that we were looking at from below. We're looking straight at it now, okay? And you see in the center of that end cap, there's a hole. And normally between that hole there, going through the middle of the detector, through the center of this actually just insulation device here, is where the beam pipe for the proton for the LHC. Whew, I'm tired climbing the stairs. is where the beam pipe for the LHC goes. Now we've actually taken out the beam pipe in this shutdown because we're going to replace it with a smaller diameter one, actually. Among other things,
ahí van las partículas. Ahorita lo removieron porque van a hacer unas adecuaciones, pero ahí básicamente está conectado con el túnel, básicamente, el tubo, ¿no? Sí.
Yeah. Este es del haz de proton.
El tubo, sí.
Okay.
Yeah.
So normally the beam pipe goes straight through here, and at the moment what you're seeing is this is a layer of basically thermal and humidity insulation.
David,